So in this talk, we will be talking about reverse engineering malware and introduction to it as a very much the introduction to the tooling, the sandboxing, the environment that you need to set up. This is not an intermediate talk, not an advanced talk. This is actually very much a beginner talk for starting security analysts. And we're going to go through the basic steps on how to reverse engineer a Windows malware, very potent Windows malware that actually hit a large company. We will talk about it about 10 months ago. It was very live, very potent. The servers are still live, so if you want to go ahead and pen test it, that's your decision. Okay, so hi everybody. My name is Abdullah, as the introducer already said. I work as a security analyst in a mobile attribution provider company. And if that is too confusing, it's basically we allow mobile marketers to authenticate installs that are coming from their advertisements. And I work as a security analyst in the anti-fraud team of the company. And previously, I worked as a software engineer. And here's my Twitter handle, so if you want to follow us. All right, so first of all, what is malware? And this definition is not made by me. This one is made by a Mr. Jake Williams from SANS Institute. His handle is Malware Jake from Twitter. He's one of the most smartest people that I know of malware handling. He's very dedicated person. Malware is a binary that does something someone wouldn't like. I hope I'm paraphrasing him right. So it's not about, I will get to the demo in a minute. It's not about an exploit. That's a misconception. Not all the time malware will actually contain an exploit. That's only the really powerful, very fancy ones. Most of the time it's actually just abusing in the Windows case, the Win32 API. In Android case, it's the Android ecosystem, the permission system. If you were in my first talk, you would see me give a talk about how the Android ecosystem was exploited in order to attack the content provider that Google Play uses. It's not a technical exploit in the security nomenclature. It's actually just an abuse of the already existing system. So more or less, it's technically legal. So we're going to go through a small demo right now about this. You know the case about the demo gods, right? You know if the demo works or not. Here's a virtual machine I'm running, Windows 10, and you see a small little exe that's called openme.exe. All right, so a free hat goes to whoever can tell me what should I do with this thing. Thank you. All right, so this is going to take around, I think, 60 seconds or so. So I will just go over here and get back to it in the next 60 seconds. So while this is actually working, why bother with analysis? Why do we need malware analysis? In my opinion, malware analysis is necessary, not antivirus. I'm not here to trash talk about any antivirus. I'm more or less unopinionated about it. But it's necessary to know that there's a difference between malware analysis and letting the antivirus people do their job. It's a very big difference. Most malware is targeted to a specific organization, to a specific people, to specific infrastructure, and a specific target. It actually has a unique signature. And if the malware writer knows what he's doing, he's going to be avoiding antiviruses. If any of you has done OSCP, I think one of the main tasks is that you have to design an exploit that avoids, that evades antivirus programs. So this is why we bother with analysis, because most automated tools can't really catch it. It's something very targeted, it's something very unique. So simple hygiene, I believe is proper word, is a very good way of protecting against such a thing. Number one rule, don't click on a exe that says openme.exe. All right, let's get back to a little virtual machine. Lovely. All right. Important information, all of your files are encrypted with RSA 2048 and AES 128 ciphers. Right, so that sounds bad. Decrypting of your file is only possible with the private key and decrypt program. This is my unique personal identification ID, and if I go to here, my wallpaper has been replaced. And if you look in here, what is the extension of this file? Osiris. Wow. That's not a file I created. That's actually a TXT file that I had lying around. It had some input in there. And all my files are right now encrypted. This is what's called ransomware. It will encrypt all your files, all the necessary, very crucial text files that you have, budgeting, anything that you and your boss talked about, all encrypted with a in this case, .osiris extension, and you can't do anything about it. This is unreadable. If you go into Notepad, this was a TXT file. It didn't even have a magic number. It had nothing. It's just a pure TXT file. Right now it's encrypted. This is what ransomware does. And if we can revert back to my virtual machine, I will get back to it right at the end. We will do a small experimentation afterwards. So we're going to deal today with a small ransomware. Before I go into the analysis, there is something about AV vendors by I think the name of the person is Brian Welton from Black Hills Information Security. Yes, I remember. They made this thing, this event, and they keep doing it every RSA, and it's amazing, and they actually have it as a webinar. So what they do is that they have a small booth. They set it up using usually an RSA conferences or Black Hat, and they literally attack antivirus vendors live. They say, download the latest version of the antivirus, whether it's, I don't know, I'm not going to name names, but they have a list of AV vendors. They go through it every year, and they basically attack it. They have a small malware. They keep changing the signature of it, and they bypass every single antivirus program out there. And as I said, I'm very unopinionated about antiviruses, but the thing is, they are not made for protection against directed attacks. You can't protect against this. There is no antivirus that could have protected against Stuxnet. That wouldn't have existed. And moving on. So, analyzing a ransomware. The name of this, the code name that Hybrid Analysis gave is openme.exe. That's the name that it was, that the large organization that was infected by this ransomware, that's the name of the exe file, openme.exe. If you go to the top right corner, you're going to see threat score of 100, and that's something from an automated analysis tool. So we can see that there's a lot of funky keywords happening. And the AV detection rate is 76%, but not 100%. Nothing can be caught 100%. So this one was, it has a lot of interesting signatures that do resemble antivirus, malware, like crypt-encrypt, the use of crypt-encrypt function for Win32 API for ransomwares, which we're going to go over later. And the steps that we're going to follow right now with the analysis is very much a surgical approach. We're not here to do an entire analysis or dissection of the malware. I don't care about what sort of SQLite database libraries that they imported. I don't care about the versioning. I only care about a very specific thing. I need to know if this exe is safe or not. And assuming that the person actually doesn't open it before he sends it to me. So we're going to follow a small methodology of analyzing this ransomware. The first one is that we're going to go with static analysis, not reverse engineering. That's a different step. That's static code analysis. Right now, we're just going to see what the properties of the exe is. Afterwards, we're going to go with behavioral analysis. Some people call it dynamic analysis. We're going to run it, see what's the inputs and the outputs, and afterwards, we're going to open it up with IDA Pro or Radare or pick your own disassembler. The thing is, a lot of, since this talk is aimed very much at the uninitiated in the malware analysis, never ever open a malware or an exe file directly into IDA without knowing what you're doing. You're going to be bombarded by libraries that you don't know about and you don't need to know about. You need to have a theory before you actually go on to an analysis. That's what the job of a malware analyst is. And IDA stands for Interactive Disassembler. So the interactive part is you. Static analysis. The format of this presentation will be that I'm using a small sandbox environment of 2 virtual machines, Unix system and a Windows system, which is the victim system, and one is the analysis system. For the Windows, for the both systems, you're going to see the either Unix or Windows colon and then the command that I'm executing. If it's a Windows GUI program, you're going to see the name of the program. I'm doing this so that later on, if you actually want to do this thing by yourself, you can download openme.exe. It's in a GitHub repo, which I have the link to at the end. It's called the Zoo. It has a pretty big, diverse range of malwares for you to analyze and have fun with. And you can execute these commands to follow exactly what I just did, and you can reach your own conclusions afterwards. So in here, we're running strings. It's basic Unix command that actually just dumps all the strings that are there in the exe file. And as we can see in here, to me, none of this makes sense. None of this is relevant. By the way, the cover story of the exe file that the infrastructure of the company found was that it's a paint replacement program. Okay? So that's what, if you're a malware analyst, this is the cover story that you're going to receive. It's like, hey, I just received this email, and it had an exe file that says, this is a better paint program. So how about you go ahead and tell me if it's real or not? So what we're looking for right now are signatures for drawing. GUI drawing. So to me, none of this makes sense. What is constructions strike banner Chinese medium? Somebody can explain to me this, he gets a free hat. So yeah, strings didn't give me any useful input right now. This is the next page of string. I like this one. Astroburn Lite is not installed. Do you want to download Astroburn Lite? I actually searched for Astroburn Lite on Google. I have no idea what this is. It's not a real software. So when you receive a software like this and it says it's a paint program, just run strings on it and see if it actually is trying to do what it says it's doing. Okay, next step is that we're still in the static analysis part. We need to know what this exe looks like. What's the imports? What's the exports? What's the libraries it's using? What's the DLLs? Stuff like that. So we run it through a small program called PE Studio. I really can't believe this program is free. It's amazing. If you have 5 minutes and your boss tells you, it's like, okay, I need to know what this malware does like now. Just throw it into PE Studio. It's beautiful. It gives you all the imports that you need, gives you all the blacklisted keywords, and highlights them on the left side, which you're going to see in a minute, and tells you basically a small summary of what it thinks this program does. Now, that's a summary of an automated tool, so just beware what you're trying to do. So it actually, from what you can see in here, it actually has some paint properties. Set pixel, I can see in here fill RGN. I'm guessing that's some sort of something relating to paint programs. Rectangle, set brush org EX, create pen. There's some interesting signatures that do actually resemble paint programs, so it could fool the eyes. So, but let's keep going. Let's keep asking questions. I said about the PE Studio, the strings, the blacklisted strings. It's right here, highlighted in red, and there is the indicators above. It will tell you a small summary of what it thinks it could be doing. And in here, I do see some interesting stuff. If you pay close attention, you're going to see two very important things in here. TLS. Okay, anybody knows what TLS stands for in 132 API? Come on. Anybody? Thread local storage, not transport layer security. It's a weird thing in 132 API. It's basically a very niche, weird little thing that Microsoft did, which is basically having the ability to store variables that is on the thread itself. And you can transport it from multi-thread applications. For malware analysis, there is a side effect for it. For a malware author, excuse me. You can execute a program before the entry. Before the actual entry point, the win main function, you can execute whatever it is that you want before it. When you see something that says TLS, 99% of the time, it will be doing something malicious. Why would you, if you're a real program or an actual binary, why would you want to execute something before the execution of the program? To fool the analyst. So if you see something with TLS, that's already a red flag. All right, so we have in here terminate process. Why would a paint program want to terminate the process of another programs? We have is debugger present? Why is a paint program trying to detect if a debugger is present? You see, there's already some like gang signs in here that you can detect for malware. When you see something like this, just keep doing some analysis. You're going to find some interesting stuff. Right now, we're going to go for dynamic analysis. What I'm going to do is that basically have the Windows victim machine, which is the virtual machine that you just saw. It will be running. It's connected through an IPv4 proxy to my analysis machine, the Ubuntu machine. And the Ubuntu machine is running just basically some traffic analysis to see what's going in, what's going out, what's the DNS requests, what's happening when I click the button, what's the requests that are being made. And there's a small Python script called fakedns.py. It has a big GitHub repository. Basically what it does is that it captures all the DNS requests and show it to you in here. It's kind of like running Wireshark or Burp or whatever it is that you want, but this is just for DNS. It's a little bit easier if you want to just know what you're exactly something specific what you need. And I see in here some Win10 API requests, and I see something in here, brb.3dtuts.by. Which BY domain name country, which country code does it stand for? Anybody? It's not so far away from here. Belarus, thank you. So, and there is a paint program that is connecting, trying to connect to a Belarusian server. It's not from Belarus, the paint program. So, let's continue on. So, we running another tool right now. We're going to have a list of tools at the end of the slide, so don't worry if you miss one of them. This tool is called initsim. It's basically what it does is that when you are throwing a PHP request, it will reply back with a small PHP header, with a small PHP page, a fake made PHP page. When you're asking, if the victim machine is asking for a JPEG, it will reply back with a JPEG. It's basically there just to continue the analysis. It's like, okay, we're throwing a request, the victim machine is still waiting, trying to get something back. It will throw it something back. It's just throwing back a dummy request, but it's nice to just continue the analysis, just to see how the execution of the ransomware just goes, how far will it go? And it actually got fooled. The brb.3dtuts.by had a /ads.php request, and the victim machine threw a payload, all of this payload, threw it to the host brb.3dtuts, and I received it in my analysis machine. And at the end of the presentation, we're going to know what the hell is happening in here. The first one is, I think, pretty easy. It's an IP address. It's my IP address. It's my local, I'm using VirtualBox, so it's my local internal network's IP address, static IP. I see in here C equals desktop, whatever. That's my computer name. And then we see P equals a huge payload. Looks encrypted. We're going to get to it later, and we're going to know what's happening right now. Right now, we have an more or less confirmation that whatever it is that's happening in here, it's not a paint program, okay? We still didn't see any GUIs. We still didn't see anything. It's connected to a Belarusian server. So at this point, you can more or less stop the analysis and tell the person who sent you this file, don't open it. So an encrypted post request, this is what we know. This is the summary of what's happening. We have an encrypted post request. We have a reference to brb.3dtuts.by. There's an interesting quote is that, I can't remember who said it, but in communication, it's not what is being said, it's what's not being said. What did I not see in the list of imports in here? I see a lot of function names. What am I not seeing? There's the internet functions, the HTTP request that made this. Where is it? It has to be made through an import, through a wininet.dll import, to be specific. That's the DLL library for Win32 API that's responsible for handling network requests. I didn't see it. It's not there. So there is no cryptography imports. None, actually. I just got infected by ransomware, so I'm expecting that the library the binary that infected me could have some cryptographic functions, like crypt encrypt. That's the #1 cryptographic functions that you need to actually encrypt stuff in Win32 API. Crypt encrypt, it's not there. It's not in the list of imports. So moving on with the analysis. We're done with the dynamic analysis, by the way. We know that it's doing something funky. We know that we need to go further. Let's actually start having a preparation for the static code analysis, for actually attaching a debugger or a disassembler for Radare or IDA Pro or whatever it is that you want. And we can start getting prepared for that part. To do that, we need to check for packers. As in a small one-liner, a packer is usually a program that is encrypting the program. A packer is a wrapper around the program that is encrypting the real program, the child binary, the one that's actually doing the work. It's encrypting it, and once you click the executable and actually try to execute it, it will unpack it, and you will have the real binary. Why does it put a small binary into a box, close it, and gives it to the client? Why is it doing this? Obfuscation. It's basically trying to hide itself from the analysis, either an automated mail scanner or an antivirus, or me, the analyst. It's trying to hide itself. And we have some tools in here to actually check for packers. It's some online tools. We can check it out in here. exe info detected easy. None of them actually detected a packer. As you can see in here, it says not packed. This tool, which is the CLI version of this tool, it's different ports. It's actually doing something different. It says not packed, has anti-debug. So it's definitely doing something funny. We didn't detect a packer, but we didn't detect any internet functionality. We didn't detect any cryptographic methods. So we still need to go through the analysis. Theory. We have two theories now. The binary is protected with a packed, it's protected with a packer. The second one is that crypt-encrypt is used somewhere. Crypt-encrypt, as I said before, is the cryptographic function that is necessary for encrypting a section of plain text. That's, if you're writing a ransomware, you will have to use this function, or you have to make your own cryptographic methods. So I'm going to go with the Occam's razor, with the easiest path is a straightforward path. So I'm just going to go to assume, as a theory, that crypt-encrypt will be used. So I need to know where is it being used, how. And the first theory is that this binary is encrypted somewhere, somehow. I don't know why, I don't know how, but I'm just assuming. Virtual protect is the method that is being used to actually change the protection of a region of memory into writable or readable or executable. So if I'm a packer and I want to unpack my child binary, I will have to use this function to map out a section of memory that I can unpack it in. And you can do this in different methods. Of course, there's 10 ways to do this thing, but this is just one of the most famous ones, and I'm going with a theory in here. I'm going to see how this theory holds up. So I'm attaching a small debugger in here. I'm using x32 debug. It's one of the variations of x64 debug project, and in my opinion, it's a great open source project. If you're using Immunity or something, I use Immunity. It's amazing, but this one, I really like it. It's very good. It has all the features that you need, and the GUI is actually nice looking. So I'm attaching this binary into a debugger, and I'm running virtual protect on it. By the way, how am I doing in time? 5 minutes. Good. So basically, we're attaching a debugger in here, attaching a breakpoint on virtual protect, and running the executable. And it hit. Virtual protect was not in the imports list, but it hit. I see it right here. How is this happening? We check that. We'll answer how is it happening later. Right now, we actually know that virtual protect is reserving a section of memory with ERW. ERW means execute, read, write. A paint program has just used virtual protect on an import that's not listed, it's hidden, and it's mapped out a section of memory with ERW, execute, read, write. So if you ask me, this is happening because it's trying to unpack the binary. Theory number one was correct. We know how it's working right now. We know that debugger is actually present, and we know that virtual protect is present, and it is mapping a section of memory with execute, read, write. We can go on. We may be able to actually get the decryption keys, which might be helpful for anybody who fell for this. So we attach another breakpoint, set BBX, crypt encrypt, and crypt encrypt description, and it hits again. The binary is being unpacked through a custom packer, not listed, not known, not UPX, not something that any of the 3 tools that I ran were able to figure it out. And it just hit 2 imports, not listed, and it just hit crypt encrypt. We will be able to, if we actually see what's the section of memory that's being decrypted, right? Not decrypted, the section of memory that's being used that is coming from crypt encrypt. It's here, 042, 0.42.38, the entire 04230 memory section is the section that was unpacked. It's the ERW section. And I see right here MZ. What does MZ mean, folks? Exactly, executable. MZ stands for Mr. Mark Zabowski, if I'm saying his name right. He's the creator of PE. He's the creator of the executable file. Just kudos to him, because he actually, from what I heard, got a lot of lawsuits, because every time somebody sees an MZ, they call him and they say, oh my God, you just created a malware. So, all right, so we just proved the two theories correct, and we were able to extract, after we took this executable read-write section of memory, we were able to go ahead and see the entire real binary, the unpacked binary, which does have, and this is the name of the unpacked binary, dumped bin. This executable read-write section of memory, it's actually a small PE file. It's a small executable. And we unpacked it, and we did see cryptographic imports right here in strings. We didn't even have to go through PE Studio. Crypt encrypt, crypt acquire context, crypt derive key, everything in here, destroy key, which is not so good for the people who actually just got their files encrypted. So you're kind of like locking the key and then just destroying it. So that's not funny. But it's doing a request, and it is sending a small payload that, I'm just assuming here, contains the encryption keys, or not. You know, the attacker could be just sending an encrypted blob of data that doesn't have anything. You send money to him, and then he's like, oh, I don't have the key. You have the key? I don't have the key. So, and this is more or less the entire analysis that we need to continue. That's the full circle. Static analysis, dynamic analysis, we know the properties, we know everything what's happening right now. And further analysis, if you continue going through this thing with IDA Pro or Radare or something, which, by the way, if you notice, I still haven't used. I did more or less everything with just using a debugger. You don't need to know assembly to do malware analysis. That's something important. It's good that you know it. It's necessary that you know it, but it's not 100% required. You can still know what you need to do if you know how to use the tooling and you know how to use the methodology behind it. As we said before, surgical approach. I think I'm closing in on time, so I'm more or less done. That's the conclusion. And what I want to take out of this is that if you're a starting malware analyst, or you just are interested with this thing, go and take a small malware from the zoo, maybe, the GitHub repo that I mentioned, or from anywhere you want, from your friend's honeypot, and try to analyze it, try to see how it goes. This one was a little bit complex, actually. This one has a custom packer. Not every binaries has a custom packer. It's a pretty unique thing, actually. Pretty hard process to write your own obfuscator and a packer. You can go ahead and do it, put it on a virtual machine, connect it through an analysis machine, run the tools that we just saw, fake DNS and inetsim, see the requests that are going in and out, and maybe you can actually know what is happening, the entire walkthrough, the entire cycle, and you'll be able to at least write a report and say, oh, this malware does 1, 2, 3 because of this imports, because of that packer, because of this and that. And you'll be able, if you're working for an IPS, you'll be able to extract signatures. Maybe you can put it into your network's IPS so that it can detect such a thing. And thank you so much for listening.
Thank you so much, Abdullah. So I bet we have some questions. Here's the first one.
Please.
Okay,
You need a third hat,
for,
don't you?
no, I left it. So thank you for, first of all, for the wonderful presentation. And what is very interesting, so when the malware, no, you got it, you missed it, and it encrypted all your files, yes? So there exist also the decryptors of the old ones, yes? Of the old malwares.
I didn't understand, I'm sorry.
So when your information is encrypted, yes? And you cannot decrypt it without the key. But as I know, there exist some decryptors for the malware that were used before, yes?
There could be, but the thing is, what this malware does is that it's encrypting it with RSA and AES. With that, from what I understand, I'm not a cryptographer, but you need a decryption key for that.
Yes.
For such a thing, there are
So
some...
my question is the decryptors that exist. So probably they have the key, yes?
Depends on the malware. If the malware generates a random key, it's
Yeah,
a
because
problem.
of it I asked. So it generates a random key, yes?
Further analysis could show you that there is a hard-coded encryption key, and then there will be a decryption key that's also static and constant across all. But it could be random. I actually didn't do enough analysis on this one to know if it's random or just a static one. So,
Okay, thank you very much.
of course. Yes, please.
So we have a mic there. Okay, so you.
Right. So,
Yes.
in your opinion, what makes a malware almost impossible, or actually impossible to reverse?
Impossible to reverse.
Yes.
I don't. When you're attaching a debugger to any binary, you're entering God mode right now. You're basically can do anything that you want. You can have the binary execute pathways that never even existed in the code base. I think the only limitation is your knowledge. You should be able to understand the enough imports and the libraries, and you will be able, without question, to do much of anything that you want. That's why a lot of real malwares follow multiple layers of obfuscation. It will give sometimes a fake sense of conclusion. It's like, oh, this is the end of the malware. No, keep looking further. Maybe there is an encrypted binary that's actually doing the real work. So, in my opinion, no, there isn't any limitation that anybody can come up with that could stop an analyst from concluding the analysis. So, thank you for your question.
You can go first if you want.
Let's go ahead. Go ahead.
Okay. So you spoke about how importing the decrypt function could be generally custom made, as opposed to actually doing it where it would be blatant. Have you ever had cases where it would be so custom that it would generally bypass most analysts' analysis, and that it would be really hard to detect because it would seem like a genuine?
I will tell you that I haven't caught something that is just bypassing any analyst, because usually if you're following the proper pathways of the execution of the binary, you will be able to know something. The thing is, this is more like a road stop, the crypt-encrypt. We know the name of the road stop. If you're like going from, I don't know, like through Europe, you're going to stop through a city or one city or something. You can't just go into null space. And you will have to stop into some road signs. And if somebody is trying to track you, he will follow those road signs. There is a possibility that it could be a custom function. I one time wrote a CTF just for a small meetup that used an XOR, basically. And it's XORing with, I believe it was OX, not dead beef, it was like something cute with the hexadecimal characters. And it was just XORing it with that, and that was the encryption function. But it was custom made by me. It was in WinMain, and in that CTF, only like 5 people out of 30 were able to get it. They really could not understand that it was as simple as an XOR. There is nothing to it. It's not crypt-encrypt. There is nothing in there. And they finished the entire thing, but through different ways. But nobody got the decryption keys. They were able to decrypt everything else, but they didn't get the decryption key just because it was so simple. So you can make your own custom functions, and it is very much possible. It's very much out there. But in my way, if you're just going through a theory and you want to prove it, the easiest thing is just to go through whatever is out there. Okay. Did I just blind some people? All right.
Thank you. So I think I have my colleague there.
We can talk later.
Okay.
Hello. Yeah, I'm here on the left.
Yes, sir.
I have a question. I was using a tool in the past, IDA. What are you thinking about it? Because I saw that it's including all these tools that you are presenting today inside. You think it's a good tool, IDA, from X-Rays?
So IDA is disassembler. It's one of the most famous disassemblers. It's one of the most expensive disassemblers too. So what it does is static code analysis. That it's basically disassembling your code, your binary code, into assembly language, into machine language. And that's something very okay, but the thing is, all of what I did right now, I try to avoid using that. Because the assembly, if you've ever read it, it's very, very hard to understand, and it's usually intimidating for everybody who wants to start out.
Yeah, but IDA in the last version is including already generating some pseudocode back in C++. It's not very good written code, but you can see it like a programmer, what is happening in the back. You don't see just disassembler.
That's very good. But
also you can see the function that they imported. You can run it with the different kind of attach, like extended debugger or passive attach to the executable. And
I hear you. So Radare is another disassembler. It also has pseudocode generation. Hopper, another disassembler, it also has it. It's very good that you can read C code, but in my opinion, if you want to follow a methodical approach, it's better not to look at code. It's better to theorize what the app is doing, what the binary is doing, and try to follow the tracing in there by executing the code, not by trying to look at the analysis. If I was writing an obfuscator to deter an analyst from doing their job, I will throw flashes in the middle of the code. Flashes basically trying to do getting some factorization for whatever, for no purpose, just to throw away the analyst. So in my opinion, don't look at the assembly, don't look at the source code, even if you have something like IDA. Follow something like this, dynamic analysis, execute it, and see what's the input and output. And then maybe after that, you can run it for a debugger. And afterwards, if you really want to know what's happening, go for IDA, do the pseudocode summary, which in my opinion is amazing. It's really good. And it's not all the time accurate, but it's very good. And then afterwards, you can have a more conclusive opinion. But the first approach is to always follow a dynamic analysis approach. That's my opinion.
okay, thank you.
Of course.
Okay, thank you so much. Thank you, Abdullah. So if you have other questions, please approach Abdullah in break.
Right after this.